Welcome to Spacecraft Guide, the channel that describes how the most historic spacecraft work. This week we will be describing the Lunar Module electrical system, which kept the machine operating on the surface of the Moon. The electrical power is supplied by 5 batteries, 1 lunar in the descent stage and 2 in the ascent stage. 2 descent stage batteries, 1 and 4, power the lunar module from T-minus 30 minutes until after transportation and docking, at which time the lunar module receives electrical power from the command service module. After separation from the command service module during power descent phase of the mission, the 4 descent batteries are paralleled with the ascent stage batteries. Paralleling the batteries ensures minimum required voltage for all lunar module operation. During the lunar stay, specific combinations of the 5 descent batteries can be paralleled to provide lunar module power. Before liftoff from the lunar surface, ascent stage battery power is introduced and the descent power is terminated. Descent power is terminated and descent feeder lines are dead-faced severed. Ascent stage battery power is then used until after final docking and astronaut transferred to the command module. The EPS batteries are controlled and protected by electrical control assemblies, relay junction box, dead face relay box, in conjunction with control and display panel. A battery control relay assembly adapts the lunar battery to the 4 descent control circuits. Primary AC power is provided by 2 inverters which supply 115 plus or minus 2.5 volts or 400 plus or minus 0.4 cycles per second synced condition AC power to the lunar module system. The operating frequency of the inverters is 400 plus or minus 10 cycles per second in the non-synced free running condition. Well, that certainly was a mouthful. What does it mean? It means that there were certain systems on board the lunar module that needed 115 volt alternating current to run, and all they had were batteries on board that were 28 volt direct currents. The inverters took that power and changed it into 115 volt power to power things like the Ordeal, the abort guidance system, even things like the Flight Director Attitude Indicator, the FDAI or 8-ball, and other systems like Rendezvous Radar that were needed to go to the moon and get off the moon. So that's what all that means. They're just talking about how they convert the power and what they're going to use that power for. Each of the batteries on the descent stage had 20 cells, weighed 135, and had 415 amp hours of life for 16 hours of power at 80 degrees. Each of the ascent batteries weighed 125, had 296 amp hours of life for 5.92 hours of life. That all means there is 64 hours of power in the descent stage of the lunar module and 11.84 hours of power in the ascent stage for a total of 75.84 hours of power at normal operation. Put another way, the astronauts had 3.16 days of electrical power on the lunar module under normal conditions. Thanks for watching this video all the way through. Please subscribe, like, and comment below. And if you'd really like to support us, please go to patreon.com/SIVRmuseum and sign up for a tier on our Spacecraft Interactive Virtual Reality Museum. And remember, if you sign up at the beginning of the month, you get the rest of the month free. So signing up on February 1st means that there'll be 28 free days to enjoy the Spacecraft Interactive Virtual Reality Museum. Thank you for your support.